we shall continue with differentiation. Differentiation. And looking at a product rule. The product rule of differentiation simply implies multiplication rule. If we are given y is equal to x squared plus 3 into x plus 5, product rule formula states simply that dy dx is equal to v du dx plus u dv dx, assuming that this is our u and that this is our v. So when they are inserted respectively, we'll be having x plus 5, which is the v, multiplied by the differentiation of u, which is x squared plus 3 with respect to x, plus u, which is this, x squared plus 3 multiplied by differentiation of v, dx plus 5 with respect to x. Now this will give us x plus 5 into, if you differentiate x squared from previous lecture, it is 2x. If you differentiate 3, is 0, so that is all, plus x squared plus 3. If you differentiate x raised to power 1, because x means x raised to power 1, it gives you 1. Gives you 1. If you differentiate 5, it is 0, so we'll have 1 here. When we open the bracket, we'll get 2x raised to power 2 plus 10x plus x squared plus 3. We have the powers that are same together to give us 3x squared plus 10x plus 3. That's it. Take note of this work. Furthermore, if we are expected to solve y is equal to x sine x. Now in this, if y is equal to x sine x, it means the product rule formula will come to play, which is dy dx is equal to v du dx plus u dv dx. So that what this simply implies from the formula analogy is that if we are having this expression as product rule formula, now procedurally it will also require the evaluation, as this is going to be u and this is also going to be v. So this just gives us that dy ds is equal to v, which is v now becomes v as it were here, now gives us sine x multiplied by the differential of u, the derivative of u, which is 1. If you differentiate x, you get 1. Now plus u. when we also look at u as a derivative, initially when conceived here, but here is going to be a value, and u now becomes x multiplied by the derivative of v. If you differentiate sine x, you will get cos x. So when we open, we'll have sine x plus x cos x. This is the final answer for the differentiation. Take note. So generally, from the first concept of differentiation, as you can see that the relationship are quite impressive on product rule, the algebraic concept, and lastly the trigonometrical concept. So product rule is very key, and the formula is dy ds equal to v du ds plus u dv dx. So you separate the value for v, which is the last value usually, and u is the first value. Then you now differentiate. Take note.